Do you know if you apply some force on an object, with what acceleration it will move? Or if you have to give some definite acceleration to an object, how much force is required? This will be clear from Newton's second law of motion. Before we come to the concept of Newton's second law of motion, it's important to know the concept of momentum. To understand the term momentum, let's review some common observations. If a bicycle is moving with the speed of 40 meters per second and hits a person on the road, the person will fall and may get some injuries. But on the other hand, if a heavy loaded truck moving with same speed of 40 meters per second hits the same person, the person may die. This is because of heavy mass of truck. Now let's take the case of small bullet fired from the gun. A bullet fired from the gun may kill the person. Here the reason is not mass, but the velocity of a bullet with which it hits the person. Combining the two cases, we observe that the impact of motion produced by an object on other object depends on its mass and velocity. So there must be some important quantity that combines mass and velocity of an object. Newton identified this quantity as moment and defined momentum of body as a product of mass and velocity. Mathematically, we can write this. As we know, the SI unit of mass is kilogram and the SI unit of velocity is meter per second. Therefore, SI unit of momentum is kilogram times meter per second. So, momentum is the product of mass and velocity. Now, coming back to the earlier example of bicycle and heavy truck, let the mass of bicycle is 10 kilograms and is moving with the velocity of 40 meters per second. The momentum of the bicycle will be 400 kilograms meter per second. Let the mass of a truck is 10,000 kilograms and is moving with the velocity of 40 meters per second. The momentum of the truck will be 4 lakh kilogram meter per second. So find momentum is larger in second case. It's clear the death of a person is due to larger momentum. If we take a case of stationary truck whose mass is 10,000 kilograms, the velocity of a truck is 0 meter per second. The momentum will be 0 as this. So we find the momentum of a rest body is 0. On conclusion, we can say momentum is related to motion of an object. Now coming to the Newton's second law of motion. It states that the rate of change of momentum of a body is directly proportional to the external net force applied. The change is in the direction of applied force. Let's try to understand it in more clear way. Let the initial momentum of body is equal to mu, where you use the initial velocity, And the final momentum of body is equal to mv, where v is the final velocity. Change in momentum will be mu minus mv. Since rate of change of momentum is change in momentum per unit time, so rate of change of momentum is this. But we know change in velocity per unit time is acceleration. That is, acceleration is this. Thus, rate of change of momentum depends directly on mass times acceleration. But according to the statement of Newton's second law of motion, rate of change of momentum is directly proportional to the net force applied. Thus, we can say force is directly proportional to mass times acceleration. To remove the sign of proportionality, we put a constant k. So we can write F is equal to k times mass and acceleration. The value of k depends on units adopted for measuring force, and it comes out to be 1. So putting the value of k in above equation, we have the final equation of Newton's second law of motion as this. With this equation, we can find the SI unit of force. As the SI unit of mass is kilogram and that of acceleration is meter per second square, so the SI unit of force is kilogram times meter per second square. And this is what we call as Newton. We can find 1 Newton as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second square. Let us try to understand Newton's second law of motion in more simpler way. If we apply some net force on an object kept on the ground, obviously there will be some acceleration in that object. Now the question is on which factors the acceleration will depend. If we first apply a force of 10 Newton, what will be the acceleration? Now if we apply a force of 20 Newton, in which case the acceleration will be more. Obviously it will be the second case. So we can say one of the factors on which acceleration depends is applied net force. More the applied force, more is acceleration. Or we can say this. Now there are two objects on the ground, one with lesser mass and one with greater mass. And you apply a force of 10 Newton on each. Surely the object with lesser mass will move with larger acceleration than the object with larger mass. This is because of lesser mass of an object. So we can say the other factor on which the acceleration depends is mass of an object. Lesser the mass, more is the acceleration. In other words, acceleration depends inversely on mass of object. On combining the two cases, we can say acceleration depends directly on applied net force. and inversely on mass of an object. Mathematically, it can be written as this, or in simple terms, F is equal to mass times acceleration. This is all about Newton's second law of motion. Do you know how rocket launched from Earth move into the space? Or how are we able to walk on the ground? How swimmers swim inside the water? What is the reason behind the recoiling of gun? The answer of all these questions lie in a concept given by an English mathematician known by the name Sir Isaac Newton, and named the concept as Newton's third law of motion. From Newton's first law of motion, we learned what's force. The second law gave us the measurement of force by establishing a relation force is equal to mass times acceleration. The third law of motion gives us the nature of force. According to Newton's third law of motion, when an object A exerts a force on object B, at the same time object B also exerts a backward force on object A. These two forces are equal in magnitude but opposite in direction and are called as force of action and reaction. Thus, when two objects interact, there occurs a pair of equal and opposite forces. The statement of Newton's third law of motion goes as: to every action there is equal and opposite reaction. That is, the force of action and reaction are always equal and opposite. These forces act on two different objects, and each force produces its own effect. Let's try to understand this with some examples. Let us take the example of recoiling of gun. When a bullet is fired from a gun, why the gun recoils and gives jerks to the shoulder of a gunman? As you can see on the right side. When a bullet is fired from a gun, the gun exerts some force on the bullet in forward direction. That is force of action. In return, the bullet exerts an equal force on the gun in backward direction. That is the force of reaction. With this force of reaction, the gun recoils and gives jerks to the shoulder of a gunman. Now the question is, if the two forces are equal in magnitude, then why is not gun moving with same acceleration as that of bullet? Since from Newton's second law of motion, we know that acceleration depends inversely on mass of object. That is, greater the mass, lesser the acceleration. As the mass of gun is much larger than that of a bullet, that is the reason the gun does not move with same acceleration as that of bullet. So we can make a statement that although the force of action and reaction are always equal in magnitude, but they may not produce acceleration of same magnitude. This is because each force acts on different objects which may have different mass. Now let's take the example of walking on ground. When we walk on the ground, our feet pushes the ground in backward direction. This is the force of action. As a reaction force, the ground pushes our feet in forward direction with same amount of force. It is this forward reaction force of ground which enables us to walk on the ground. Now the question is, why walking becomes difficult on the ground covered with snow or sand? Since when we push backward on the ground covered with snow, some of our action force is lost in compressing the snow, and our feet exert smaller action force on the ground. As a result, the forward reaction force of ground also reduces. That is why walking becomes difficult on the ground covered with snow or sand. In the same way, when a swimmer swims in the water, he pushes the water backward by an action force. The water pushes him forward with same amount of reaction force, which enables him to swim in the water. In a rocket launched into the space, the fuel burned appears in the form of hot and compressed gas. These gases are made to escape through a nozzle in the downward direction and produce an action force on the air. The air produces the same amount of reaction force on the rocket. As a result, the rocket moves upwards with same force. This was all about Newton's third law of motion. Law of conservation of momentum is direct extraction from Newton's third law of motion. From Newton's third law of motion, we learn that when two objects interact with each other, there appears a pair of equal and opposite forces. That is, when object A exerts force on object B, at the same time object B exerts equal and opposite force on object A. Suppose two objects A and B of mass MA and MB are moving towards each other with initial velocities UA and UB. After collision, suppose the object A exerts force FAB on object B. At the same time, object B will exert equal and opposite force FBA on object A. That is, force FAB is equal to minus times FBA. Negative sign indicates forces are in opposite direction. After collision, the objects will move with different velocities. Suppose object A moves with velocity VA and acceleration AA, and the object B moves with velocity VB and acceleration AB, and the collision lasts for time period T. We shall assume that no other external unbalanced forces are acting on the objects. That is, collision is ideal. Now, after having all parameters, we shall proceed as, since interaction forces are FAB is equal to minus times FBA, from Newton's second law of motion, force is mass times acceleration. Thus, we have the relation this. But we know acceleration is change in velocity per unit time. So we have the final relation as this. On further solving the above equation, we get the final equation as this. But we know from definition of momentum that momentum is product of mass and velocity. So MA plus MB is initial momentum of object A and object B, and MA plus MB is final momentum of these two objects. So the above equation gives us the total momentum before collision is equal to the total momentum after collision. That is, total momentum remains unchanged after ideal collision. That is the law of conservation of momentum. So the statement of law of conservation of momentum is, when two or more objects interact with each other, the vector sum of their momenta remains unchanged or conserved and is not affected by their mutual action and reaction. The only condition is that no external unbalanced force should be acting on the system of bodies. As the law of conservation of momentum has been extracted from Newton's third law of motion, all the examples of Newton's third law of motion can be explained in terms of law of conservation of momentum. Let's take the example of recoiling of gun. Suppose mass of gun is m1 and that of bullet is m2. Initially they are at rest, that is velocity is 0. As initial velocity is 0, then initial momentum is also 0 because momentum is mass times velocity. When a bullet is fired from a gun, let the bullet moves with velocity v2 and the gun recoils with velocity v1. So the final momentum of system of two bodies will be m1 v1 plus m2 v2. From conservation of momentum, m1 v1 plus m2 v2 is equal to 0, as initial momentum was zero. On solving the above equation, we get the relation as this. Negative sign shows that bullet and gun move in opposite direction. From this equation, we get velocity of gun depends inversely on its mass. Since mass of a gun is much more greater than mass of bullet, so the velocity of gun has to be much more less than that of bullet in order to satisfy the above equation. Similarly, other examples of Newton's third law of motion like rocket launch, swimming can also be explained using law of conservation of momentum. This was all about law of conservation of momentum.